For decades, the issue of climate change due to carbon dioxide emissions has been recognized and attempted to be solved on a global scale. However, many people in our society fail to realize the other side of the issue, which some would argue is a larger issue. This issue is the ocean's rising acidity. The ocean's acidity is rapidly rising due to the absorption of carbon dioxide on a global scale. This issue has existed since the early to mid-20th century and has only gotten worse in the recent years. This human disturbance is not only changing the pH of the ocean, but is also killing a majority of the aquatic ecosystems of our oceans due to this change in the ocean's delicate geochemical balance.
When carbon dioxide and seawater are combined, an acid known as carbonic acid is formed. This acid is what is responsible for lowering the pH of the seawater, putting the lives of many aquatic life forms in danger.
When emissions initially happen, our oceans quickly absorb around 25 to 30% of our carbon dioxide emissions very quickly. But due to air mixing at the surface of the ocean, it can absorb more than 85% of carbon dioxide emissions in the long run.
Over 530 billion tons of carbon dioxide has been emitted and absorbed by the oceans, and with an estimated 1 million tons per hour and 22 million tons per day, ocean acidity is a problem that is gaining intensity quickly and needs to be stopped.
Due to the carbon dioxide emissions that are currently going on in the modern age, one result that has been seen from these emissions is the fact that the pH of the ocean is dropping very rapidly. For example, before the industrial era, the ocean's pH was 8.2. However, in just 50 to 80 years, the pH of the ocean has dropped down to 8.1. Although this change seems very small, with only a 0.1 pH drop, a change similar to this without human intervention should take anywhere from 5,000 to 8,000 years, in contrast with the 50 to 80 years that this pH change has happened.
With CO2 emissions rising by the day, emissions could drop 0.4 pH in this century and 0.7 pH beyond the next, further harming the ocean's delicate biogeochemical balance.
So after learning about all that information, you may be asking yourself, why does rising ocean acidity even matter to the ecosystem of the ocean? Well, the absorption of CO2 within the oceans forms about 89% of bicarbonate ions, with 10% being formed to carbonate ions, and 1% being formed to dissolved gas. This unique biogeochemical ratio is extremely important for the current ecosystem of the oceans, as many of the organisms in that ecosystem have adaptations and have evolved to live in specific conditions with the specific ratio. For example, organisms such as snails, urchins, clams, and crabs use the carbonate ion, an abiotic factor in their ecosystem, to construct their shells and skeletal structures.
However, this increase in emissions is not beneficial, as most of these organisms are required to live in a very narrow pH and dissolved CO2 range. The increased carbonic acid decreases the amount of carbonate ions in the ocean and increases the amount of dissolved gas within the water, throwing off the ratio necessary for the marine life to live.
Due to the deterioration of the abiotic factor, carbonate, that could happen with increased CO2 emissions, many of the marine wildlife cannot protect themselves with the compound responsible for protection and skeletal systems. Although aquatic life hasn't been affected by this change in pH much yet, evidence from earlier periods of carbon dioxide increase reveals that ocean life has suffered mass extinction from earlier periods. If the rate of carbon dioxide absorption and emissions continues like it has, and the ocean keeps dropping in pH, the adaptations made by the aquatic life will not be able to keep up with the change, and it will kill off most of the life within the oceans, causing generally a mass extinction.
The obvious solution in this case would be to cut down on CO2 emissions, which seems simple but is more complicated than it sounds. This can be caused by the burning of fossil fuels as well as the global industry. The USA has been making efforts to switch to solar power in more arid climates such as Southern California, Arizona, Nevada, that have better access to the sun more hours of the day. The amount of rooftop and commercial solar systems have risen almost 500% between the years of 2010 and 2013 in the United States. The US and China have also announced new actions to reduce carbon emissions in the past few years. China has pledged to peak its emissions before 2020, and the USA has already begun reducing their total emissions and is well on track to meet the goal of reducing emissions by 17% by 2020. If rates of emissions die down, there will be less of an increase in carbonic acid, helping the delicate ecosystems of the ocean. The US government has been enacting these policies on reducing carbon emissions, but there are some things that we as individuals can do to reduce our specific carbon footprint. For example, you could drive a low emissions vehicle like a Prius or a Tesla, as well as recycling and possibly, even though it's fairly expensive, investing in a solar power system for your house. All of these things reduce emissions on a small scale, but if everyone did them, the country would definitely see results as a whole.
One other solution besides altering emissions that has been attempted by scientists is to throw off the pH drop by taking advantage of the dissolved carbonates formed from the carbon dioxide and seawater mixture. However, as of right now, it has been scientifically revealed that the acidification of the ocean occurs much faster than the sediment could throw off the pH of the ocean, which deems the solution useless for right now. So ultimately, the only solution to fix this rising ocean acidity is to control emissions of carbon dioxide. So hopefully after this iMovie you can understand how much of a problem the rising ocean acidity is, and when looking at the issue of carbon dioxide emissions, you'll not only take into account climate change, but you'll also take into account this issue of rising ocean acidity. Thank you for watching.